All right, so 12.2 is all about circles. Okay, so the one thing you need to know for circles is the standard equation for a circle, which is x minus h squared plus y minus k squared equals the radius squared. Okay, where the hk is your center and the r equals the radius. So for number one, it says write the equation for a circle with a center of 1, -5, and a radius of square root 10. This is just plugging in, right? This is my h, this is my k, and this is my r. So x minus 1 squared plus y plus 5 squared should equal the square root of 10 squared, which is what? 10. Good. Questions on that one? Raise your hand if you got it right. Okay, good. All right, write the equation for the circle with the center at -4, 4 and containing the point -1, 16. So I have the center, right? This is my HK, but what am I missing?
The radius.
The radius, and how do I find it? Good. So the distance between the center and this point on the circle, so I'm not going to draw it because it's like 1 and 16. But let's say that this is a point on the circle and this is my center. If I find the distance between them, this would represent the length of the radius, which is what I'm missing. So the second formula you need to know, distance formula, x2 minus x1 squared plus y2 minus y1 squared. And it doesn't matter which one you pick as your 1s or your 2s, right? It's just the distance between them. So if this is my x1, y1, and this is my x2, y2, I get the square root of -1 minus a -4 squared plus y2, which is 16, minus 4 squared. 1 minus a -4 becomes, or sorry, -1, -1 plus 4. And then 16 minus 4 is 12 squared. So this is 3 squared plus 12 squared, square root of 9 plus 144, square root of 153. Is that a perfect square you know off the top of your head? No, it doesn't exist, right? It's not a perfect square. It's somewhere in between 12 and 13, but we don't have an exact value. But we don't need an exact value because no matter what that number is square rooted, at the end, when I plug it back into the equation, I'm going to square it again. So I don't even have to simplify it in the meantime. So now I'm plugging in my center, which was h is -4, k is 4. This is my h. This is my k. And if my radius is the square root of 153, then I get x minus a -4, which becomes plus 4 squared plus y minus 4 squared equals the square root of 153 squared, which is what? 153. Raise your hand if you got that one right. Good job. Okay, if you didn't, were you on your way, just found a mistake or something like that? Everybody clear on it now? Yeah? Okay. All right. 12.3 is ellipses. So this is the last of the information that's going to get covered on your test, which is next Thursday, a week from today. So it's 6.3, 6.5, 6.6, which were the, the graphs, the functions, the inverses, all that stuff was chapter 6, which is on your quiz, and then the 1, 2, and 3 from this chapter. Lauren? Oh, that? All right, so we know what ellipses are because we got introduced to them in 12.1. They were like elongated circles, right? Like ovals, okay? If you pulled the center of a circle apart in 2 points, it would stretch the circle into an ellipse. So while your circle is completely round, distance from the center to all the sides is the same, your ellipse is different. So it's either going to be wider than it is tall or taller than it is wide. The longer axis, so the one that is wider or taller, is called the major axis. And it passes through passes through both foci. So a foci is a point along the major axis, which you'll see in a minute. The end points of the major axis.
Is that the way you pronounce it?
Foci?
Really?
Yeah. Okay. The shorter axis is called the minor axis, and the endpoints are the co-vertices. So you've got vertices on the major axis and co-vertices on the minor axis. Okay? The major axis and the minor axis are perpendicular, so where they meet would be a 90-degree angle, and they both intersect at the center of the ellipse. So takeaways, minor axis, major axis, and along the major is the foci and the vertices, and the minor axis has the co-vertices.
We're sure that the minor axis.
All right, standard form of an ellipse. So now you've got standard form of a circle. We're going to add to it standard form of an ellipse, okay? These two, okay, both have a center at 0, 0. So that's the first kind of ellipse we're going to talk about, is what happens if the center's at 0, 0, and then eventually, probably tomorrow, we'll get to where we shift it around, okay? But both of these would appear to be like this. So your center's at 0, 0, this one's at 0, 0, okay? The first one is called horizontal because it's wider than it is tall. The second one is vertical because it's taller than it is wide. The major axis is along the horizontal axis for this one, and the major axis is along the vertical axis for this one, okay? So horizontal, vertical. Along the horizontal, on that first one, along that major axis, you see these points, which are your foci, okay? Each individual one's called a focus. And you find that from the distance from 0, and you find a value for C, which we're going to get to in a second. And then each of the vertices are going to be A distance away from the center, and each of the co-vertices are B distance away from the center. And there's a relationship between A, B, and C, which, again, we're going to get to in a second. Ian?
Wait, so what's the difference between the focus and the vertex?
So the focus falls within the ellipse. It's going to be inside it, not on it.
Why is that important?
Because you can have two of those three and find the third. So that it's like, if you think about Pythagorean theorem, a squared equals b squared equals, or a squared plus b squared equals c squared, there's a relationship between those three.
And is it always near the vertex, or is it just like on the line?
It could be further in, depending on where the vertices are.
Okay.
Yeah, but it's always on the line in between the center and the vertex. It's never outside. Okay, all good questions. And then notice that on the vertical one, the foci are now here. Okay, these are called your vertex or your vertices, and these are your co-vertices.
So the focus, whatever, are always going to be on the major axis?
Correct. Okay, and these are what the equations look like. So the horizontal one is x squared over a squared plus y squared over b squared equals 1. The vertical, now the switch happens. The y doesn't have to come first, but a is the larger of the two. If the x is over the a, then it's a horizontal one. If the y is over the a, it's a vertical one. So the A is always the larger of the two. A is always bigger than B. That's how you can identify which kind of axis it is. Is the bigger number under the X? If it is, it's horizontal. Is the bigger number under the Y? If it is, it's vertical. The foci is, remember I said the distance is C in each direction. From the center to the foci would be C. And then the vertices are A for the major, for the regular vertices, and B for the co-vertices. And this is the relationship I was just referring to. So C squared equals A squared minus B squared, because we're not forming the right triangle, we're actually forming the part outside of it. So C squared equals A squared minus B squared. Yep. So when you look at it, and this is for me, I'm a visual person, like I start to look at these like, okay, so say this is x squared over 36, and this is y squared over 25, and it will be equal to 1. So standard form would be equal to 1. You want to look at this, and the very first thing you can identify from this is which denominator is larger. So the larger one is always a. Okay? These are squared. So a squared would equal 36, and b squared would equal 25. Because the larger number is under the x is the axis that is the major axis, which means that this is a horizontal. Does that make sense? So I can switch, now if I switch that, if the larger number is under the y, the a is still 36 because A is always the biggest one, But now the larger one is under the y, which is telling me that the larger axis is the y-axis, which is vertical. Does that make sense? Okay. So order doesn't matter. Like in this little diagram that's in your book, the y comes first here, but it doesn't have to be. It's just you want to look for which one's larger. Ian.
So, like, I get that 2A and 2B is the length of the axis of the axis.
Yep.
So when you find just A and B, is that like the radius lengths for each one?
Sort of, except that it's not a radius. It's the distance from the center to the vertex, but they're different, right? Like A has to be different from B.
Yeah.
So it's sort of like it if you want to look at it that way. Yeah. All right, so this is just going to ask you to write the equation, but I'm going to challenge you to start like visualizing it so you can kind of wrap your head around it. So it says write the equation in standard form for each ellipse with a center at 0, 0. So I want you to actually plot these things. So it says vertex at 6, 0. So I know my center is here. And the vertex is 6, 0. Where's the point 6, 0? Along the x-axis or along the y? X. So 1, 2, 3, 4, 5, 6. Which means my other vertex is where? Negative 6. 1, 2, 3, 4, 5, 6. And then my co-vertex is at 0, 4. Now this is along my y-axis. So this is what my ellipse looks like. Question so far? God bless you. So is this vertical or horizontal? Horizontal, right? It's widest along the x-axis, which makes it horizontal. Which means the a squared is going to go under the x squared. With me so far? If it's horizontal, then x, which is your x-axis, right? Think about it that way, gets the bigger number, and a is always the bigger number. If it's vertical, then y gets the bigger number, which is the a. So now the distance in between this here, 6, 6, those are your a's, right? So a is 6, which means a squared is going to be 36. And the distance from 0 to the co-vertice, which was 4, is your b. So y squared goes over 4 squared. That's it. So you've just got to identify which kind of ellipse is it? Is it horizontal or is it vertical? And then figure out your A, your B, and then square them and put them underneath the correct variable. Ian?
I don't understand how, like, is it asking you to solve it if it's horizontal or vertical, or does that affect the answer?
That affects your answer. So that's going to affect, so you know your A is 6, right? Because your vertex is always going to be your A, and your co-vertex is always going to be your B. So I know the distance from 0, 0 to 6, 0 is 6. I know my A is 6, but I need to know which variable gets the A. And that's figuring out if it's vertical or horizontal. If it's horizontal, the X gets the A. If it's vertical, the Y gets the A.
Is the question going to ask us, like, is this going to be horizontal or vertical?
No, your answer would tell you that.
Okay.
So when I look at that, I know that that's horizontal because the bigger number's under the X. Does that make sense? Okay. Try it. See if you can do it. All right, so same set of directions. Write the equation for standard form for each ellipse with a center at 0, 0. So the 0, 0 tells me I'm going to get x squared over either a or b, and then y squared over a or b equals 1. Now I got to figure out which one gets the a, which one gets the b. So what is a? And try to do this without having a visual. A is 5. It's going to be the larger of the two. So this is a and this is b. Okay. Now I just got to figure out, is this a horizontal or a vertical? So if my vertex is at 5, 0, 1, 2, 3, 4, 5, negative 5, 0, already I can tell that if that's my A, This should be what kind of ellipse? Horizontal, which means which one gets the A? The x, good. So this would be 5 squared, and this would be 3 squared, or x squared over 25 plus y squared over 9 equals 1. Good so far? Okay, so now this one gives you a little bit different piece of information. It says, same set of directions, write the equation in standard form for each ellipse with a center of 0, 0, but this time it gives me the co-vertex is 4, 0, and the focus is 0, 3. So what letter does the co-vertex give you? B, okay? The A is the vertex, so the 4 is the B. What letter does the focus give you? C. We still have to have the A. So do you remember the relationship between those three? Good. C squared equals A squared minus B squared. So C squared would equal A, well, let me fill in the C, sorry. 3 squared would equal A squared minus 4 squared. 9 equals A squared minus 16. Add the 16. A squared equals 25 and A equals 5. So if I was to graph this, center would be at 0, 0. My co-vertex is 4, 0. 1, 2, 3, 4. 1, 2, 3, 4. If that's the co-vertex, that means my vertex goes the other way. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. The foci should fall along the same line as the vertex. So the fact that this is 0, 3 confirms to me that I've done this correct. Is this horizontal or vertical? Vertical, which means now the x is going to get the b and the y is going to get the a. So x squared over 4 squared plus y squared over 5 squared equals 1. Because the b was on the x-axis.
Oh, okay, so
I plotted that first. Yep. Ian.
Is that an A and a B on the, or is that 6 on the points? When you put equals what?
This is a B and this is a C. So the co-vertex gives you B and the focus gives you C. Okay, same set of directions, write an equation in standard form for each ellipse with center at 0, 0. This time they give you the co-vertex at 5, 0. So 1, 2, 3, 4, 5. Here's a co-vertex, which means the other one. 1, 2, 3, 4, 5, and be at negative 5. What letter does that 5 represent? This is B, co-vertex is a B, and the focus is at 0, 3. What letter is that? C. So 0, 3, 1, 2, 3. It's going to be up here. 1, 2, 3. So all those things already tell you what kind of ellipse this is, which is what? Vertical. Okay, so I know the A is going under the Y. And then, again, C squared equals A squared minus B squared. 3 squared equals A squared minus 5 squared. 9 equals A squared minus 25. 34 equals A squared, and A would equal the square root of 34. So if I wanted to graph this, I would approximate 34. Square root of 34 is in between square root 25 and square root 36, right? It's a little bit closer to 36. So I know that this is bigger than 5, but less than 6, if you think about it that way. So if I went up another 1, 2, 3, I know it would fall before 6. 1, 2, 3, fall before 6. You don't need to figure out what that exact value is. Because when we plug it back into the equation, what do we do with the square root of 34? You're going to square it. Good. So this would be x squared over, well, the b goes under here. So b goes under x squared. Y squared would be over square root of 34 squared equals 1. And then I would square the square root. 34. Raise your hand if you got it right. How many of you were on the way? Questions? So a lot of you did not raise your hand. You're okay? Yes? You're just done? Yeah, okay.